Okay, this question says, during a research experiment, it was found the number of bacteria in a culture grew at a rate proportional to its size. At 7 a.m., there were 4,000 bacteria present. At noon, the number of bacteria grew to 4,600. How many bacteria will be there at midnight? So we're going to use our exponential growth and decay model for this example, which is A equals A naught e to the kt. So let's make sure we know what each one of these things are. A naught is our starting amount, or we mostly say initial amount. K is our growth or decay rate. T is time. And A is going to be our ending amount after whatever period of time we have. So in this example, it says at 7 a.m., we have 4,000 bacteria. Then at noon, we have 4,600, and we want to know how many we have at midnight. So I want to take these times of the day and convert them to a time that we can use in a formula. So we're going to say that 7 a.m. is our beginning time, and then we'll figure out how many hours later that will be at noon. So starting at 7, we have 8, 9, 10, 11, 12. So 12 is noon, so T equals 5. And then midnight is 12 hours later from noon, so 12 plus 5 would be 17 hours. So our ultimate goal is to fill in this missing piece of information, how much bacteria is there at midnight. But in order for us to do that, we need to figure out K, the growth or decay rate. In this case, it's growth. We grew from 4,000 to 4,600. So what we're going to do is we're going to focus on just these pieces of information here so that we can figure out what that growth rate is. So what I'm going to do is I'm going to use the 4,000 as my starting amount, the 4,600 as my ending amount, and T equals 5 as my time, and I should be able to solve for the growth rate. So I have A equals A naught e to the kt. I grew to 4,600. I started at 4,000. I don't know the growth rate, but after 5 hours, I grew from that 4,000 to 4,600. So now I'll be able to solve this exponential equation for K. First, I'm going to isolate that exponential. I isolate it by dividing both sides by 4,000. Okay, I can reduce that a little bit. These zeros cancel out, and I have 46 over 40. See, those are both even, so into 46 would go 23 times. 2 goes into 40 20 times. I have e to the 5k. Then I solve this exponential equation by taking the log of both sides. I can use the power rule to bring that 5k out front. Natural log e is equal to 1. So I have 5K equals natural log 23 over 25. Divide both sides by K, and now I have the growth rate. Natural log of 23 over 25. I apologize. I changed that 20 to a 25 for some reason. Let me put it back to 20. 23 over 20. 23 over 20. All over 5. So that is our growth rate. And now that we know our growth rate, we're going to be able to find that missing value that we talked about up here. We're going to use 4,000 as our starting amount. We're trying to figure out our ending amount. We're going to use time as 17, and we're going to use that growth rate that we just found. So in our formula, A equals A naught e to the kt. We started off with 4,000 bacteria. And K we just found to be natural log of 23 over 20 over 5. And our time is 17 hours. Remember, we started at 7 a.m. That was time equals 0. Midnight will be 17 hours later. And we'll put that in our calculator. So we have 4,000 E. And I like to put the 17 in the front. It's a little bit easier to type in the calculator. So do 17 times the natural log of 23 over 20, close parenthesis for the log. Then I need to divide by 5. So we have 1.1084 times 10 to the 15th. So that means we've got to move that decimal place 15 places to the right. So that's 4 places. That's 15 places. All right, that number looks a little bit big. So I'm looking back over at my calculator here, and I see that I'm missing a division sign. So let's fix that. Let me type that in again. 4,000 e to the 17 times the natural log of 23 divided by 20. So now I've got that division sign there, and then divide by 5. That's a little bit more reasonable. That jumped up way too much. Okay, so now we have 6,433 bacteria at midnight. Thank you for checking out my videos. Have a great day.